Welcome to our class's midterm reference table review and a brief review of what we've done for the first half of the class. With the midterm approaching, I would like to tell you that there is a review posted. You should work through that review. You do not have to submit it. It is optional, but it will help you study for the exam. There also is a file with the midterm reference tables. You may print them and use them on your exam. That is the only outside resource you'll be able to use, but you may use them. Clean copy. We're going to talk about those tables in this video, and it will kind of walk you through what we've done the first half. The first table we look at is basically, if you recall, the lithosphere, hydrosphere, troposphere, the first three main spheres of the Earth, and this gives you the composition of each. So basic information on what each is made of can be gotten from this table. The second table that you have is a very important table when we talk about minerals. This table gives you mineral properties like luster, hardness, cleavage and fracture, colors, the uses. So you don't have to memorize all of the properties. Also, each specific mineral, the information is given to you. So when asked questions about minerals on the midterm, this table will come in very handy. The rock cycle, because after minerals we discussed rock, this rock cycle gives you the three major types of rocks, how they form, and how they turn into other types of rocks. So this table is very helpful on general rock questions. Now there is an ID table and a property table for each specific type of rock. First are the igneous. You can see you have all the different types of igneous rocks here, and from that you can find out what its texture is. Very coarse would be intrusive, forming deep, taking millions of years to form with huge crystals. And as you move up, the crystals get smaller and smaller, and they form closer and closer to the surface of the Earth, where pumice and obsidian, the glassy ones, form almost instantaneously. There's no time for the crystals to form. You can also see the color. Light color contains lots of quartz, and you can see the quartz in the mineral composition corresponding with the light color. Also lower density, and we call that felsic. So all that information can be gleaned from this table, as well as mafic, dark and less quartz, more of the heavier minerals. So you can get a lot of information from this table. I urge you to go back and review the lecture and some of the work you did during Module 1. The metamorphic and sedimentary rock tables are here. Looking at sedimentary, clastic are pieces of other rocks glued together, and the Wentworth scale gives you the grain size. Crystal generally are evaporites, so you have water evaporating, leaving behind halite or gypsum or even calcite for chemical limestone. But limestone can also be clastic. Those are the fossils together. And then you have coal, a bioclastic plant, referring to the bio being compressed together. The metamorphic rock, foliated, have bands due to their forming, whereas non-foliated don't. And you have the parent rock given, and then the metamorphic rock, what it turns into. You also have the composition of each. After we finished rocks, we move to geologic history. This table basically summarizes everything you need to know. The Precambrian, the first eon, takes up 7/8 of Earth's history, and it's composed of the Archean and the Proterozoic. You can see the major events that occurred. Just a side note, the years are given in millions. So you have 4,600 million years as the estimated origin, which is 4.6 billion years. So keep that in mind if you're looking at billions, that this chart is in millions, and you may have to do a quick conversion in your head. The most recent eon, the Phanerozoic, is composed of the Paleozoic, Mesozoic, and Cenozoic. Those are the eras, and you can see further divisions, periods, and epochs, and the major events that have occurred during each of these. This map, lots of information can be taken from this map. Obviously, you can read latitude and longitude, so you can find various locations. The three types of plate boundaries, the transform, divergent, and convergent, are graphically summarized in the key. You can see the various plates named. You can see the hot spots where the mantle plumes are and what's being formed there, like Hawaii or Yellowstone. You can see subduction zones. You can see areas where crust is being built at the divergent boundaries. So this map summarizes what we need to know for plate tectonics. When you go down into the earth, this summarizes the layers of the earth, their composition, and their properties. You can see, you can find the density, the temperature, the pressure. You can find the melting point and whether it's a solid, a liquid, or one of those plastic solids, the asthenosphere with the plastic mantle, the solids that flow because it's right on that temperature range. You can also see that the density of continental crust is a little bit less than oceanic crust, which is less than the mantle. So density increases with depth, temperature changes with depth, pressure changes with depth. You get all of this information right from this chart. The last chart that we have is the two earthquake waves and their relative travel times. So you can see one of them is traveling a lot faster, the P waves, than the S waves, which are slower. If you have the difference, the time lag, you can determine epicenter distance using this. You can get a lot of information from this chart as opposed to, or in relation to earthquakes. So those are the graphs and charts that you will have to use on your midterm. And you also have a review exercise associated with the midterm. So as you study for the midterm, make sure you have a clean copy of these and make sure that you complete the review. Thank you for joining me. Good luck on your test. Make sure that you email or text me any questions you may have, and have a great day.